So my name is Jung. I'm the kernel developer at Wolfram Research. So topic today here is geometry, data, and 3D printing. So simply say it's the 3D printing through Mathematica. So we did try 3D printing area before, but at the time we only have the graphics. And roughly say that just graphics alone is not enough for 3D printing. We also need some information about like geometry and geometry of models, something like that. And from like version 10, we add lots of new functionality about the region, I'd say mesh region, so computational geometry area. And those functionalities actually help a lot to go further in 3D printing area. So here's just brief the workflow for 3D printing. So first, we need data. So I'd say the model to print. So there are a couple ways in Mathematica to get the model from various area. And after that, we need to verify the model we want to print is decent. So there are also some function we are developing for helping those kind of stuffs. At the end, the printing. Okay, so first about the data. The first easy one is constructor. We have a couple of built-in constructor in Mathematica. For example, like an implicit region, and then if you use another function, discretize region, then you got the mesh region, and this one, you can just send it to print and print out. Here's the new type of constructors, Spinsky mesh, something like this. And also we have another one called Menger mesh. And also you can derive new mesh region from some other mesh region using some operations in Mathematica easily. And second type of model you can get it from Mathematica is the curated data. There are various curated data in Mathematica, and area is keep expanding. So one simple example is example data, geometry 3D. Here, this is a list of geometry 3D example data. You can extract from Mathematica. And here's the basic, the graphics. And then now, we add mesh region or boundary mesh region, so you can just get directly the mesh region from example data. And another type of curated data you can get is polyhedron data, chemical data, solid data, and surface data. Also some like anatomy data, and there is much more. And even for example data, we will expand the collections. So you will soon much more collection than now. And also this is just traditional way to get data from Mathematica. So just use import. So this is example STL file. I scanned downstairs and just import to Mathematica. And here's some new functionality, the newer version, the plot theme. And using the smooth shading, I got something more realistic, the mesh now. And for the import, we also improved a lot. So like STL, we also supporting PLY, OBJ. OBJ we supported before, but now it's much faster and getting more data. So there are some improvement. And then this is also new functionality, geometry 3D data. Actually, this opened the connection between Mathematica to the outside service, like a Thingiverse. This is an example of Thingiverse. So I think everyone knows the Thingiverse, what it is. And then here's the one example. So you can just search the cat in the Thingiverse, and it gives you a list of the IDs that containing the cat. And each model have various properties. One of the properties is thumbnail. So you can see the thumbnail of each ID. So here's the result. So this is all corresponding to these IDs up here. Also, you can just extract mesh region. Then this is the mesh region you can use in Mathematica or print out. And here's another example. So now I just want to get the newest model in Sing inverse and show the thumbnail. And this is the result of models. So, okay, so when you get the data, now it comes to validate the model is okay to print or not. So for example, like I just here the list of things you need to check before you send your model to the service called Shapeways. So it's from their website, the documentation. So you need to make sure your mesh is watertight and need to be thickened some areas, something like that, blah, blah, blah. Okay. But with just graphics, it's very hard to check these things. But when you have a mesh region, it has some information inside already, like geometry and topology, etc. So one of the things we are doing right now, we develop function easily check these things. So for example, like a closeness. So this is related to here, your mesh needs to be watertight. So it doesn't allow any hole or any of those things. So this is one of the functions we develop. If you evaluate this with your after you downloading this notebook, it will not work because it's in the development kernel. So I'm just gonna show how what kind of function it is. So it's just simply check closeness of this mesh here. Definitely it's not. And then after that, you can extract the edges which make this mesh region not closed. And after that, eventually we're gonna have some repair function to repairing this defect on the mesh. Another example of this function is like orientation. This look kind of decent, but actually this mesh is not oriented. I mean, coherently oriented, what I mean is. So by checking this, running this function over this mesh, you say this false. That means there are some polygon which is not oriented correctly. And with this function, you can find out which polygon actually have the problem with it. So after you got it, you can reverse the orientation to make it correct, and then using the new model to print out. And also, other than these two functions, we also plan to develop several other functions, like check thickness of mesh. So thickness, what I mean is if you have mesh with, for example, like this one, this is very thin area. This one, if you put this into 3D printer or 3D print service, they say, no, this is too, shallow. So you need to thicken this kind of area. And other than the validate, checking defect and repairing, we also have some certain operation you can do over the mesh region to modify your mesh. For example, like extrusion and union and cut it. Cut it is extrusion, the intersection, and for example, like Brin region, region union, region intersection. Yeah, this function will work on even 3D mesh region soon, so that is other thing you can do. And so you have model, and then you validate the model if it's okay to print out or not. And last thing you need to do is actually printing. So one traditional way to print in Mathematica is export the function, export the model, and then using the resulting file to print out. And we want to make that process a little bit easier. So we put some new function called printout3D. So actually, if you just run this, then you got some list. This is a list of service print or local printer that's supported by this function. So we have like cube, form1 plus imaterialize. This is printing service, makeable, this local printer, and these two are also some outer service. So how we use it? So for example, this is one example. So printout 3D will open up 3D printers programs. For example, like I put the Legion ball here, and then want to send this model to MakerBot. So if you evaluate it, this will open up the MakerBot and put your model into MakerBot software. And now you can print out using this one. Same thing for Cube. It will open the Cubify and send the model to there. Another scenario is if you don't have any local printer in your home, then what you can do is you can send this model to online services to print out. So one of the examples is Sculpteo is one of the online services that sending you print if you upload your model to their site. So in this case, if you evaluate it, this will connect to their server, their services and open up the the web browser. And you see the model I just sent here. And then you can order it and you can change the type of material you want. And even you can change the size and then just review and check out, pay it, and they will send you printer. So yeah, this one we will keep expanding the supported service. Now we have like 3 services listed here, but we will keep talk with the external services and keep making some deal to provide nice interface to Mathematica. And also for the local printer, we are also working on with local printer vendors. And the best scenario is instead of open up their software, we want to really directly connect to printer like 2D printer does. But currently it's kind of not easy to do it because there's things we need to work a little bit more. But that's our kind of final goal, to make it easy to all those processes. So this picture here, all the model here is made by Mathematica, or some from Curated Data, and I think most of you already seen the downstairs, right? So here's this model. I get this from the anatomy data and print out. It's Mathematica, and this one, this is scanned model I think yesterday. And if anyone recognizes your face, then you can have it. We cannot find it yet. But this is our team member chip. And this one, we just imported to Mathematica from, I don't remember exactly which side was it, but this one was anatomy. And this one created by the implicit, implicit region, something like that. And this one, actually, we sent this data to Shaperay. And this is what I got from them. So this is kind of very popular area right now, so we will keep working on and we will keep improve. That's our plan. And actually, this is end of talk.